Hey everyone, and welcome. Today, we're going to take a deep dive into the world of high school geometry. It's a subject that can feel super abstract, kind of rigid, and let's be honest, a little intimidating for a lot of us. But what if I told you it's undergoing a massive transformation? Let's explore the journey of geometry, from how it's always been taught to where it's headed now. Ah, yes, the question. The one that has bounced off the walls of math classrooms for, 100 years? It's the ultimate challenge from every student, and today, we're actually going to answer it. We're going to look at why we learn all this stuff and how teachers are making those lessons feel more real than ever.
Okay, so first things first. To really get where math education is going, we have to understand where it's been. And for over a century, the game plan has been surprisingly consistent. It's all been built on this bedrock of logic, proofs, and theorems.
For most of us, this probably looks pretty familiar. This exact sequence, Algebra 1, Geometry, Algebra 2, and then onwards to Calculus, this has been the standard college prep track for generations. It's a very structured, step-by-step progression, and it was designed with one big goal in mind: getting students ready for those high-level, calculus-based STEM fields at university.
And what's really interesting here is the flow, right? You start with the absolute basics: a point, a line, a plane. But then, almost immediately, you jump into reasoning and proof. So before you even get to the really complex shapes, you first have to learn how to build a logical argument. The shapes themselves are almost just a vehicle for learning how to prove things about them. And this, right here, gets to the very heart of that traditional approach. See, the blueprint for geometry isn't just about making you memorize the Pythagorean theorem. According to educational standards, like these ones from Ohio, a huge goal is just teaching you how to think. It's about building a solid argument piece by piece, and then being able to look at someone else's argument and spot the flaws. Now that is a skill you can use absolutely anywhere. But teaching logical thinking is one thing. Answering that classic question, when am I going to use this? Well, that means you have to make these abstract ideas feel real and tangible. And that whole process, it starts way earlier than you might think. And this is just such a brilliant way to make learning fun. I mean, in elementary school, geometry is a physical thing. You're literally using your arms to make an obtuse angle. You're going on a scavenger hunt to find parallel lines on the monkey bars. You're building entire cities. The goal here is just to connect all these new kind of strange words, like lines, rays, and angles, to the world kids already see and play every single day. Okay, so that's all great for a fourth grader, but high schoolers, they need a different kind of connection. The stakes are higher, the concepts are way more complex, so how do you bridge that gap and keep them from just zoning out? Well, the answer for a lot of educators is something called project-based learning, or PBL for short. So instead of just solving a problem on a worksheet, students get to use geometric principles to tackle a real-world design challenge. And a perfect example of this? Building a bridge. A project like the Toothpick Bridge challenge basically turns students into engineers. They're not just handed a formula. They have to go research why one truss design might be stronger than another. They create these super detailed blueprints where every single angle matters. Then they build it, and the final exam is seeing how much weight their bridge can actually hold before it shatters. Every single step is a direct application of geometry. And the impact is it's huge. As high school math teacher Nicole Bruce points out, when students are deep into a project like this, class just flies by. They're not watching the clock, they're solving a puzzle. And their confidence just soars, because they are seeing their knowledge create a real, physical thing that actually works. Now, project-based learning is a fantastic tool, no question. But some educators are thinking even bigger. They're actually questioning the entire structure of that century-old math pathway. And they're asking, is one single road really the best way for every single student to get where they're going? So on one side, you've got that traditional path. It's a single track, mostly designed to get students ready for STEM careers. Think engineering, medicine, that kind of thing. But what about everybody else? Well, on the other side, we're seeing the rise of these alternative pathways. The whole idea is to offer different math tracks that are just as challenging, but a whole lot more relevant to a way wider range of careers. So what do these actually look like? Well, a future nurse might get way more out of a deep dive into statistics and probability than they would from advanced calculus. A future journalist could actually use data science to analyze trends and tell incredible stories. The key idea here is that the math is tailored to your destination, giving students the specific skills they will actually use in their jobs.
So when you put it all together, you've got the foundational logic, the awesome hands-on projects, and these new, super flexible pathways. A completely new picture of math education starts to come into focus.
And at the very heart of this whole shift is a really powerful idea, and it's captured perfectly by teacher Robin Allison. The goal is to move away from this myth of the math person. It's this belief that math isn't some talent you're born with, but it's a skill that literally anyone can develop, as long as they can see its value and its relevance in their own life.
So, ultimately, here's the bottom line. This evolution in math class, it isn't about making it easier, it's about making it more meaningful. The big goal is to create a system that keeps standards high, but offers what people are calling relevant rigor, a really challenging math education that's directly useful for each student's future, whatever that future might be. And that leaves us with one final thought. For centuries, math has been about finding that one single correct solution. But as we've seen, the future of teaching math might be less about that single destination and more about providing a map with many different routes, empowering every student to navigate their own unique journey.